Okay, everybody should have notes at their desk. The notes are the reading lesson, the periodic table, and then of course I passed out a periodic table, a blank one. We're going to be looking at both of these today. Okay, so the periodic table, getting the idea. Marco, why don't you read that first paragraph for me?
As you have learned, an element is one of the basic substances that combine to form all other substances. An element cannot be broken down into simple substances. By ordinary chemical names, scientists have identified about 117 elements. Information about them has been organized into a chart that can be used to understand the chemical properties of each element.
Okay, so he said that an element is a basic substance that combines to form all other substances. Now, he said that the elements have been organized onto a chart. What is that chart called?
Periodic table.
The periodic table. So next, we're going to read about the periodic table of elements. Okay? I'm going to read the rest of this page because the rest of this page is really a review of what we've already learned and been tested on last week. So as we're reading through it, you should notice, oh, I already know this stuff. This is just a review. If you notice that you are lost and you don't know it, then you need to come see me for tutorials to catch up with the rest of your classmates because you're behind. Okay, so as a review, let me read it to you quickly here. The periodic table of elements organizes the elements according to their properties. Go ahead and underline that. It organizes them according to their properties. The table includes a box for each element with information about the element. Look at the box for carbon. The large C at the center of the box is the symbol for carbon. Each element has a unique chemical symbol. The box also shows the element's name. Recall that the smallest unit of an element is the atom. Atoms are made up of smaller particles called protons, neutrons, and electrons. Protons and neutrons make up the center or the nucleus of an atom, and protons have a positive electrical charge. Neutrons have no charge. They are neutral. The third type of particle, electrons, are located outside the nucleus, and electrons have a negative charge. Would you agree that this is all review? This is stuff you should already know? Good. Okay, as the key shows, the box of an element has a number called the atomic number at the top. An element's atomic number is the number of protons in the nucleus of the atom of an element. Each element has its own atomic number. So right here, they just told you that atomic number is equal to the protons in the nucleus. Look at the box for carbon. It shows that the atomic number of carbon is 6. A carbon atom always contains 6 protons. In a neutral atom, the number of protons in an atom is equal to the number of electrons. So now they're telling me if the atom's neutral, which all on the periodic table are, right? That I know that protons are equal to electrons. If I put that together, I get my APE. Remember APE? Atomic number, protons, and electrons are all equal. And that's what it says here. It says, so the atomic number tells you both how many protons and how many electrons are found in each atom of an element. Okay, make sure you're writing what I'm writing and underlining and circling what I'm doing. Atomic mass is the mass of one atom. The unit for atomic mass is the atomic mass unit, or AMU. Protons and neutrons each have an atomic mass of about 1 AMU. The mass of electrons is often ignored because it is very small. So an atom's atomic mass is approximately equal to the number of protons and neutrons in its nucleus. Protons and neutrons would be P plus N. These are all formulas we've already talked about. You've already been tested on these, okay? This should be review. Now, if we turn the page, this is the new information that we're learning now. We're going to learn about periods and groups on the periodic table. Okay, Michaela, can you read periods and groups for me?
Periodic table, shown on the next page, arranges elements in order of increasing atomic number. Each row in the periodic table is called a period. Periods group is also called a chemical family because elements in the same group normally have some similar properties. Some families in the periodic table have names. Group 1 is the alkali metals. Group 2 is the alkaline earth metals. Groups 3 through 12 are the transition metals. Group 17 elements are the
Halogens.
Group 18 elements are the noble gases.
Okay, so she told us that a period is a row on the periodic table. Remember yesterday's activity? When we were looking at a row, what did those have in common? What did the periods have in common? The rows? The same number of what? Energy levels. The same number of energy levels. The periods, the rows, the ones that go this way, had the same number of energy levels. Now the groups are the columns on the periodic table. That means they go up and down. What did they have? Good. The same number of valence electrons. Those are our groups. You do need to know those two. That is something you will want to know by your test. We'll be taking notes on them today and tomorrow and the next day, and we'll be doing practice on them all next week. Remember that a group, it says, can also be called a chemical family, or sometimes we just say a family. So you may hear it referred to as a group or a family. So now let's go label our periodic table. Let's label our periodic table. On your periodic table, we just talked about periods. Periods were the rows. They run this way from left to right. They're horizontal. So this is a period. It's a row. Row 1 only has 2 elements. If you go all the way across, you only see hydrogen and helium. This is row 1. So we're going to label that. That's our period. And periods, what did we say they have in common?
The same number of energy levels.
Good. The number of energy levels. So period 1, hydrogen and helium both have 1 energy level. Period 2, if you see the little 2 here, that's period 2. That would be lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. They all have how many energy levels? 2. That's why they're period 2. Makes it easy for you. Period 3 will have how many energy levels? 3. 4, 5, 6, and 7. Now, we've never actually drawn 4, 5, 6, or 7 because we haven't learned how many electrons fit on those energy levels. We've only drawn 1, 2, and 3. But you can know that, like here, nickel will have how many energy levels? 4, because it's on the period 4. Okay, the other thing that I need you to look at, or that we've read about, it's on that bottom shelf, is the groups and families, okay? If we look at the columns, they go up and down. The columns go up and down. These are called our groups. Remember, we said the groups are sometimes called families. So it's the group or the family. How were groups and families? What did they have in common? No, energy levels was the period.
Oh, valence electrons.
Right, valence electrons. So they had the same number of valence electrons. Now we're going to represent valence electrons by a little circle. So draw a little circle by valence electrons. And we're going to go through each one of these groups and we're going to see how many valence electrons do they have. Now it's pretty easy. Kind of yesterday we looked at there was 1, 2, 3, 4, 5, 6, 7, and 8. Okay, but there is a little bit of complication to it. So I'm going to show you that right now. Group 1, or family 1, has 1 valence electron. So put 1 in a dot for valence electrons. Group 2, this one right here, has 2 valence electrons. Group 3 through 12, kind of draw like a bracket here. They're kind of the goofy ones. They have either 1 or 2 valence electrons. They don't follow their group numbers. They have either 1 or 2 valence electrons. And then it goes back to normal again. Group 13 over here, you actually have to subtract 10. It has 3. Group 14 has 4 valence electrons. Group 15 has 5. 16 has 6. 17 has 7. And 18 has 8 valence electrons. So yesterday, or even what we've been talking about so far, is we've only been looking at the first 3 rows. So kind of if you look here, if I take my periodic table and hide that middle section, see how it goes? 1, 2, 3, 4, 5, 6, 7, 8. That's what we looked at yesterday outside with our activity. But when you include these that we really aren't learning right now, it kind of messes up your rows. Yes, sir?
Why are we subtracting 10?
You subtract 10 from the group number because that gives you the number of valence electrons.
Is it going to be like those on every?
You only subtract 10 from this side down here. If you subtract 10 here, you wouldn't get 2. These are equal.
More than these?
Okay, so those are our valence electrons. Now the other thing that we just read about was that these groups kind of have got names for themselves. They've gotten together and they have some names. So our groups can also be called different names. Instead of group 1, 2, 3, 4, 5, they may have special names. So if you remember, group 1 was called the alkali metals. So I'm going to put AM here, and then I'm going to come up and make a key that AM stands for alkali metals. Group 2, she said, was the alkaline earth metals. So I'm going to make a key for AEM and put alkaline earth metals. Group 3 through 12, she told us, was the transition metals. So I'm going to put TM. Then over here, we're going to label it the transition metals. Okay, 13, 14, 15, and 16, they didn't give us any special names for them. But they said group 17, do you remember what they were called? If you look at your reading, the halogens. So we'll put an H. They were called the halogens. Anybody remember what group 18 was called? The noble gases. Good. So we'll put NG. So those are our group names. So you can call it group 1 or you can call it the alkali metals. Most times when people are talking about the groups, they call it by their group name, especially noble gases. They don't ever say group 18. They just say, oh, our noble gases. And that's this whole group, this whole column. Questions so far? Yes? We'll be getting to what this black line is in just a little bit. Let's go back to read about it, and you can tell us what it means. So, Jeffrey, why don't you read this first paragraph here about metals?
Metals, nonmetals, and metalloids. The periodic table group elements based on shared properties. More than 75% of the known elements are metals.